Hello, my dear students. How are you all? I hope you all are fine and well at your home and take necessary precautions against COVID-19. In this science lecture, we are with chapter Force and Laws of Motion. In previous lectures, we have seen what is cause of motion, what is basic laws of motion, that is first law of motion, second law of motion and third law of motion. Who gave these laws of motion and few important derivation and very important and conceptual numericals of second law. In the last lecture, we have discussed about third law of motion. What is third law of motion? For every action, there is reaction, and that reaction will be equal in magnitude and opposite in direction. So third law states that if I apply force on anything, it will have equal reaction. Magnitude is equal. If I hit this ball with little force, it will apply little force on my hand. If I apply more force, it will apply more force on my hand. And another thing, notice that this direction of force will be opposite. If I apply force in this direction, its reaction will be in this direction. If I applied force in this direction, its reaction will be in opposite direction. So magnitude is equal and direction will be opposite. Let's see one very interesting and conceptual example of third law. If we take one balloon and one string, what we do? We will hang one string like this with hooks, and the string will be like this. Take one balloon and inflate the balloon full, that is like this. I inflate the balloon and tied this balloon with string. So air will not escape from this balloon. Now what should I do? Now I attach one straw on this balloon and attach this straw in such a way that this string should be passed through this. This string should be passed through this straw. So I have one straw that I have to attach on balloon by some tape or say glue, and I have to pass this straw through this string. So arrangement will be like this. Now what I have to do? I cut this thread or release this thread. Now what will happen? We all know that air will be try to come out from this balloon. At that time, air applies force on balloon air is escaping in which direction? Air is escaping in this direction. So the force in this air is in this direction, and opposite force, in the last lecture we have discussed that no force can act alone. There is always couple of force. There is always pair of force, and this pair or this couple is always in opposite direction. So if one force in this direction, so obviously the other force will be in this direction, that will be equal in magnitude and opposite in direction. Now we can observe that this balloon will move in this direction. So think what will happen in this situation. Air which is escaping from this balloon exert force on this balloon. So escape of this air is in this direction. So the force in the air is in this direction. So this air exert force on the balloon which is in different direction. So we can observe motion of balloon in this direction. All our rockets and missiles work in same principle, that is third law of motion. What is happened when we release missile or rocket? We have rocket propulsions, and when this propulsion get fired, there is a plenty of smoke came out from this rocket, and this smoke exert force in this direction, exert force in downward direction. So the opposite force that is act on this rocket, that will be in opposite direction. So when this propulsion fuel get fired, then lot of smoke came out with huge force and huge velocity. So the force acts in downward direction. At that time, opposite reactive force will be applied on rocket. So the rocket will move in opposite direction, that is in upward direction. So I hope now you understood what is the concept behind rocket flying. So this is the application of third law of motion. So I hope now onwards you can see in which case or in which real life case we have these laws of motion, say first law, second law, third law. My dear friends, I would like to say that we can learn science only by observation. If we have such kind of sight that we can see science in our everyday life, then and only then we can learn science. I must say you that this textbook contains topic of science. Where these topics come from? This topic came from observation. People like us observed things around us, and they try to find cause behind that. They try to find cause behind that and deeply study that particular phenomena. Why this is happening, what is the nature of this phenomena, and then they publish research paper. And this research paper will be studied by scientists and professors and some big organizations, and then it allowed to publish this scientific research paper, and then this experiment, this scientific research paper will come to us, and we will study it and try to apply in our everyday life. So that's how science work. Let's take another example. I hope you remember experiment of gun that we explain in third law of motion. In that we have seen one special kind of force. Remember, try to remember that force, name of that force. I will tell you later. So the experiment is like this. Take a test tube like this. Pour it with some water. Pour it with some water and apply stop cork on its mouth. Now hang this test tube with stand. Hang this test tube with stand. And apply heat on it. And apply heat on it by burner. So what will happen? This water starts boiling and gets converted into vapor. Now what will happen? This vapor try to push this cork. This vapor will try to push this cork. When in this tube there is enough vapor and enough vapor pressure that can throw this cork out. When there is enough pressure built in this test tube, what will happen? This cork will move in this direction. It will throw out in this direction. When this cork throw in this direction, opposite force will be act on this test tube, and this force will be in this direction. Why? Because there is a force on cork in this direction. So in opposite direction and same amount of force acts on this test tube. So this test tube will move in this direction. So something like this will be happen. There is a test tube. Suppose this is the test tube and this is the cork stop. This is the test tube and this is the cork stop. When this cork stop will move in this direction, what will happen? This test tube will move in backward direction. Something like this. You can imagine that when this cork stop move in this direction, at that time only this test tube moves in backward direction. So this test tube gets force. Now I told you to remember the force that we given name in example of gun. What was that force? That force was a recoil force. I hope you retain this name of force, that is recoil force. This recoil force will act on this test tube. So by this recoil force, this test tube will move in backward direction and this cork stop will move in forward direction. Now my friend, important concept. We know that mass of this cork will be less compared to mass of test tube, because it has water and this test tube is with good glass material that will not blast after heat it. So this test tube weight is larger than weight of cork. Force on cork and force on test tube are equal. Now if we consider acceleration, I hope you got the point. Force in test tube and force on cork are same. So I write MT AT is equal to MC is equal to MC AC. What is MT? MT is a mass of test tube. AT is the acceleration of test tube. MC is a mass of cork and AC is a acceleration of cork. Now we know that if mass of this test tube will be more, acceleration of this test tube will be low. And if mass of this cork will be low, acceleration will be large. So by this experiment, you can observe that if this cork goes to somewhat say 2 meter farther from this stand, will you think that if I cut this string and still I arrange some arrangement in that way that this test tube can also go in this direction, will it cover same distance that covered by this cork? Of course not. You can think about that. Suppose this cork goes further 2 meter. 2 meter goes in this left direction. Do you think this test tube will also go 2 meter backward in this direction? No, it will not. Why? Because test tube has greater mass. So acceleration in this test tube will be low. So I hope now you understood that less acceleration in gun compared to acceleration in bullet. So this is the example of third law of motion. From that we can understood how third law exists in our everyday life. Now we have important concept that is called conservation of momentum. Now I hope you know and you remember what is momentum. Momentum is nothing but mass into velocity. You know that momentum denoted by letter P and it is equal to mass into velocity. Let's take one example to derive formula of conservation of momentum. We have two balls, say A and B. We have two balls, that is ball A and ball B. Mass of ball A is MA and mass of ball B, that is MB. Initial velocity of ball A is UA and initial velocity of ball B, that is UB. And consider this UA is greater than UB. Why I took UA is greater than UB? Because I want to collide these masses or say these two balls. If velocity of ball A is more, what will happen? It will travel with more speed and collide with ball B. So at one moment this mass A and mass B will collide what will happen? Collision will happen between this mass A and B, or say ball A and B. At that time, ball A applies some force on ball B. Let's this force called FAB. That is force exerted by A on B. And by third law, we know that same force will be exerted by force BA. That is, same force will be exerted by ball B on ball A. And let's consider time of this collision is T. After this collision, we know that there will be difference in velocity of these two balls. Now, this both ball will not move with the velocity u and ub. It will some different velocity. Let's say these two ball now move with the velocity, that is final velocity VA and VB. So the velocity of ball A is VA and velocity of ball B is VB. Now we know that this force AB is equal to force BA, but this force is in opposite direction. So if we take a right side force as positive, we have to take left side force as negative, or we can consider in either way. If we took left side force as positive, we have to take right side force as negative. Let's take FAB is equal to minus FBA. What is FAB? FAB is force exerted by A on B, and FBA is force exerted by B on A. So force is nothing but rate of change of momentum. Force is equal to MA, and this M will remain same, and V acceleration is V minus U divide T. By this method, we can derive this formulation. Mass of ball A is MA. Change in velocity, that is acceleration of ball A, that is final velocity minus initial velocity divide time t. And for ball B, that is minus MB VB minus UB divide t. For sake of simplicity, I write this portion here, that is MA VA minus UA divide t. So this T get cancelled. Now I simplify this equation. MA VA minus MA UA is equal to minus MB VB plus MB UB. Here we have minus sign, so this minus sign will be changed to plus sign. Now I change this MA UA to this side and MB VB to this side. So MA VA. Now I take this MB VB to opposite side, that is plus MB VB is equal to, here we have MB UB, and I take this MA UA to opposite side. This is minus, so this will be plus MA UA. Now I change side of equation, that is I write MB UB here, this portion this side and this portion this side. So I can write MA UA plus MB UB is equal to MA VA plus MB VB. So this is our relation for conservation of momentum. I can read this equation like this. For ideal collision, momentum of ball A and ball B, initial momentum of ball A and B will be equal to final momentum of ball A and ball B. This is initial momentum, this is final momentum, this is initial momentum, this is final momentum, and this is momenta for before collision, and this is momenta after collision. So for ball A and B, momenta before collision will be equal to momenta after collision. So we can say that momentum is conserved. What is meaning of conserved? Conserved means total magnitude is not changed. Total magnitude will not change. Suppose I have some value, consider 50 unit. So I will have this total also 50 unit. This may change between A and B. This 50 will be by 30 plus 20, or this 50 will be maybe by 25. So we have total momentum conserved. This conservation law, energy conservation, momentum conservation, charge conservation, are basic and fundamental laws of physics, and that is very important in science or say physics. So I hope you understood what is conservation of momentum, what is real life application, and example of third law of motion. Thank you.